All right, everyone, welcome back to the land of Chem. I am your host and the author. My name is Jeffrey Drum. Thank you all so much for joining me again.
All right, everyone, welcome back. Now, prepare yourselves as we are about to embark on a new series presenting the most extensive evaluation of the mechanisms of operation driving the Egyptian pyramid chemical engineering systems, starting today with part 1, the Red Pyramid Primary Steam Reformer. Ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's intro, so without further ado, let's get right to it. All right, everyone, here we go with tonight's episode. Now, to begin, the Egyptian pyramid chemical manufacturing sequence is initiated at the Step Pyramid of Saqqara, and the natural gas extraction operations that were presented in episode 125. Methane is not only a valuable fuel, but also a critical primary source of hydrogen utilized in industrial chemical synthesis reactions, specifically in this case, within the Red Pyramid of Dashur, a structure that was designed with a series of internal chemical reaction chambers, the end product of which is an aqueous ammonia solution, ammonia gas dissolved into water. And although the process itself has a strong resemblance to our modern-day Haber process, there is a significant difference in the product, where today we manufacture liquid ammonia, ammonia gas supercooled until it condenses into a liquid form, whereas the ancient process product is aqueous ammonia, again, ammonia gas dissolved into water, a crucial detail that will be relevant when we reach our discussion on the mechanisms of operation within the final synthesis chamber. Now, if you take a look at this comparison between the first apparatus created by Fritz Haber for synthesizing ammonia and the configuration of the three chambers within the Red Pyramid, his inspiration becomes crystal clear. And it is a known fact that Fritz Haber was fond of vacationing in Egypt and did so numerous times throughout his life. And this industrial-scale ammonia synthesis reactor project, developed in the early 1900s, was bankrolled by an Egyptian financier. And I believe that by reverse engineering the Red Pyramid, the same way that I have, old Fritz Haber discovered the ancient industrial chemical manufacturing system that I am about to describe today, which, as I have proposed in episode 142, this ancient ammonia pyramid chemistry technology has its genesis in lightning. Attempting to literally catch lightning in a bottle by creating reaction chambers that can turn nitrogen from the air into ammonia, the most important agricultural fertilizer that has ever been created. And the process that Haber developed in conjunction with Carl Bosch implements a series of reactions that begin with methane as the primary reactant and the source of the hydrogen syngas that is combined with atmospheric nitrogen from the air in the final synthesis chamber. The exact same sequence that I have determined was occurring within the three chambers of the Red Pyramid. And don't forget, as discussed in episode 72, Alchemical Symbolism of Ancient Egypt, Part 1, that the etymology for our modern word for ammonia traces directly back to ancient Egypt and the deity Amun, who, of course, is the god of fertility. And you can see the two sheaves of agricultural material growing out of his crown here, an esoteric symbol for the knowledge of the gods, ancient industrial chemistry, and the synthesis of ammonia-based fertilizers. Now, let's examine the primary steam reformer and the series of mechanisms of operation that drive the chemical reactions occurring therein, which convert methane and water into hydrogen and carbon monoxide, starting with the methane inlet located in the northwestern corner of the primary steam reformer, that I have documented on numerous site visits into the Red Pyramid, including the upflow staining directly above the methane inlet, indicating its function to introduce natural gas into the reaction chamber. Next, stage 1, filling the chamber with water. So here you can see some very old photos from inside the Red Pyramid showing a variety of details that will be discussed in this series. For now, let's focus on the staining formations that are found in the lower rectangular portion of the chamber. This crashing, wave-like pattern that is found in the southeastern corner of the primary steam reformer that flows around the bottom of the chamber before crashing back up into the northwestern corner. These fluid dynamics were demonstrated in episode 70, Red Pyramid Fluid Dynamics Modeling Series Part 2, and the communication encoded in the Egyptian pyramids, where we simulated the water injection process coming from the inlet shaft located at the bottom of the northern pump shaft in a container with the same proportions as the lower rectangular section of the Red Pyramid primary steam reformer. And this still unexcavated inlet shaft is shown on the diagram here. Now, remember, these two crashing wave-like formations, as you will see the exact same pattern revealing itself in these fluid dynamic modeling demonstrations. Check this out. All right, now that the initial water filling process has been demonstrated, the next basic mechanism of operation is raising the water level to compress the methane gas into the upper vault. In this closed system within the primary steam reformer, this will increase both temperature and pressure within the reaction space. And in episode 48, the basic physics involved in this step were also demonstrated. And I'll put in a few clips now from that episode so you can see the system and these basic principles in operation. And note the pressure gauge and markings in the first video, which will indicate the pressure increase inside of the container. Check this out.
All right, everyone. I hope you're enjoying the video. And please remember to subscribe for more content if you're interested in the technology of ancient civilizations utilizing physics and chemistry and the function of the Egyptian pyramids and other ancient structures from around the world. If you want to help support the channel, you can pick up a copy of the Land of Chem book and grab some merch at thelandofchem.com and for access to exclusive content. Subscribe to the members-only channel now with 19 massive research episodes revealing some of my most groundbreaking discoveries thus far. Links to everything in the video description below. Thank you all so much for the support. Now, back to the video.
And a huge thank you to friend of the channel, John Sage, for his work on the inlet shaft and these fluid dynamics models. It was really cool to see this system come to life, and we may have more in store in the near future. So now that the fundamental principles have been demonstrated. Let's put it all together, and I will walk you through, step by step, all of the mechanisms driving the chemical reactions within the primary steam reformer. Now, for reference, this is by far the most accurate diagram that I have found showing the exact configuration of the red pyramid reaction chambers, with the northern pump shaft here, the water inlet here, the primary steam reformer, the secondary air reformer, the drain shaft, and the final synthesis chamber. And for now, we are going to exclude the operation of the northern pump shaft, as there is some special magic happening in this component that will be a topic for a future video in this series. So now, for illustration purposes, I'll be using this diagram to show exactly how the system works, starting with the methane inlet. So step 1 is to fill the chamber with water until the connecting shaft between the first two reformers has been filled. This isolates the space within the primary steam reformer, and it sets the initial pressure and temperature conditions within the chamber. This will be important for some calculations that will be coming up in part 2. Next, the methane fill process is initiated, and the methane gas, which is lighter than air, will rise up, flowing into the upper reaction vault. The process continues until the reactor is filled with methane gas. And the next step will begin, further increasing the water level inside the chamber, which will begin to compress the water-insoluble methane gas into the upper reaction vault, gradually increasing both pressure and temperature. The process continues, utilizing the water to compress the methane further into the reaction vault like a plunger pushing up on the gas, further increasing the temperature and pressure within the system. The water level is raised until it has reached the 7th tier in the vault. This feature will be explained in a future episode, and the reaction between the methane gas and water producing hydrogen and carbon monoxide will proceed. Now, let me run through all of these steps without narration so you can watch the process in action. All right, now, let me introduce a few terms that are important regarding both the physics and chemistry within the primary steam reformer. First, adiabatic compression. Adiabatic refers to a process in which no heat is transferred into or out of a system, and the change in internal energy is only done by work. In our case, regarding the function of the red pyramid, the water compressing the methane gas into the upper reaction vault. Most processes in thermodynamics are diabatic, which means they transfer heat. The A at the start of the word adiabatic means without, so adiabatic means no heat transfer. Often, adiabatic processes are accomplished in an insulated container where the process happens too quickly for heat to be transferred. Furthermore, for an adiabatic compression, decreasing the volume of the system, like a piston, the temperature must increase. This is specifically relevant in the case of the red pyramid, where within these limestone chambers, there will be minimal dissipation of heat during the reaction sequence. Limestone has exceptional heat-resistant properties, where, in contrast, black basalt, for example, will absorb and maintain heat. So in this stage, there is no heat exchange. Thus, adiabatic compression occurs. If you compress a gas in a closed system without allowing heat to escape, an adiabatic process, increasing pressure will increase temperature. This happens because work is done on the gas, raising its internal energy. For example, compressing air adiabatically in a piston will heat it up. So this increase of both temperature and pressure are the basic physics mechanisms of operation that drive the chemistry inside of the primary steam reformer, the conversion of methane and water into hydrogen and carbon monoxide. But, as always, this is just the tip of the iceberg, the Physics and Chemistry 101. And in the next episode, I will be addressing a few interesting articles and their implications for the function of the Red Pyramid primary steam reformer. And for those of you that have been paying attention, of course, they involve both catalysts and electric fields. This one here, scale up studies on electrically driven steam methane reforming. This work is devoted to scale up parametric studies of a new reactor for the steam reforming of methane driven by electrical current. The main distinguishing feature of this type of reactor is the use of direct electrical current flowing through metal particles to heat the whole reactor volume. Electrical current flowing through metal particles, you say? Seems like we may have discovered dozens of various types of metal particles in the Red Pyramid chemical analysis data. But there's more. This article, Improving Nickel Catalysts Using Electric Fields, a DFT, an experimental study of the methane steam reforming reaction. Stating here in the abstract, this work demonstrates the benefits of applying an external electric field to the methane steam reforming reaction in order to tune the catalytic activity of nickel. Through combined DFT calculations and experimental work, we present evidence for the usefulness of an electric field in improving the efficiency of current methane steam reforming processes, namely by reducing coke formation and lowering the overall temperature requirements. Oh, nickel catalysts, huh? Well, guess what we also found in the Red Pyramid chemical analysis data? Nickel. So like I said at the beginning of the episode, this series will be the most comprehensive, in-depth, and extensive evaluation of the physics and chemistry-based mechanisms of operation that are involved in every single chamber of the Egyptian pyramids. I will be working through all of these systems and chambers, one by one, revealing details that are going to blow the roof off of these structures, with the Red Pyramid being the smoking gun of ancient pyramid chemical engineering technology. So in the next episode, we are going to continue with the primary steam reformer, introducing electric field catalyst chemistry, and some calculations revealing both the temperature and pressure capabilities of this system, driving reactions into the secondary air reformer. And later in the series, the final synthesis chamber and a special episode on the northern pump shaft and external reservoir. Then we will move on to the bent pyramid. And if you're new to the channel and your mind is completely blown by all of this information, I highly recommend getting caught up by watching the Red Pyramid playlist so you can be up to speed on all of this data as we move forward in the series. And if you haven't already, please subscribe so you don't miss out on what will prove to be the most important research videos that I have ever produced.
First, a quick announcement. The Land of Chem 2025 Ancient Alchemy and Ascension Tour is on, and bookings are now available with almost a year to plan ahead. This is my most extensive and immersive tour thus far, covering the entire country of Egypt and all of the ancient sites, including Saqqara and the Serapeum, the pyramids of Dashur, the newly opened Grand Egyptian Museum, private special permission access to Abu Sir, the pyramids of the Giza Plateau, and a private entry into all three chambers of the Great Pyramid of Giza at night. Then we fly to Upper Egypt to explore Luxor Temple, Karnak Temple, Dendera, the Temple of Seti I, and the Osireion, followed by a Nile cruise to investigate the Hatshepsut Temple, Kamombo and Aswan, Abu Simbel, and finally Elephantine Island, possibly one of the final resting places of the Ark of the Covenant. This is a once-in-a-lifetime opportunity to experience the best of what Egypt has to offer. So if you are interested in joining, please send me an email with the subject line 2025 Egypt Tour to contact@thelandofchem.com, and I will send you the full tour itinerary and pricing details. Thank you all so much, and I will see you soon in Egypt.
All right, everyone, that is it for today's video. This was episode 156 the Egyptian Pyramid Chemical Engineering Technology Part 1, featuring the Red Pyramid Primary Steam Reformer. I really hope you enjoyed today's video, and in the next episode of the series, Sunday Site Visit 101. This is an episode you do not want to miss, so if you haven't already, please subscribe to the Land of Chem here on YouTube, and remember to click that little notification bell so you don't miss out on the new episodes that premiere twice per week. Please like, comment, share, and stay tuned. If you want to help support the channel and get access to exclusive research, check out the Land of Chem members only channel and thelandofchem.com. If you want to pick up a copy of the book or grab some merch, both linked in the video description below. If you want to follow me on Instagram or on X, my handle is @thelandofchem. Also, don't forget, after you finish watching this video, please go subscribe to our other channels, Ancient Odysseys, Let's Go with Lex and G, and for all you cat lovers out there, Egyptian Trash Cats, the best channel on YouTube. Also, all three linked in the video description below. Ladies and gentlemen, as always, thank you all so much for the support. I think that is it for today's episode. I will see you next time. Yo, are you still watching this? Please subscribe to the Land of Chem here on YouTube and click that little notification button. New videos coming out every single week. And check out this other episode. Come on, do it. Do it now.